Good day, everyone. I am Cal David B. Atienza, a public secondary school teacher under the Department of Education Division of Marinduque. Today, I will discuss the distribution and abundance of blue worms, Archipheretima species, relative to soil moisture content in three different types of habitat in Bintakay, Mogpog, Marinduque. The diversity of living things naturally varies depending on the location on Earth. The soil is home to several kinds of animals, and among them, earthworms form a major component. The burrowing and feeding activity of earthworms, as well as their overall population, is affected by different soil factors, which includes temperature, pH, soil texture, and moisture. With the effects of climate change now progressing as evidenced by the increasing temperature, soil moisture will significantly decrease. Increasing temperature will mean low moisture content of the soil impacting on the density of blueworms. Hence, this study was conducted to determine the distribution and abundance of blueworms relative to the soil moisture content in three different types of habitat in Bintakay, Mogpog, Marinduque. Specifically, the study aimed to first describe the vegetation cover and dominant soil texture of the three study sites, determine the soil moisture content in the three study sites, determine the abundance and distribution of blueworms in each habitat, and last, state the implications of the results of the study. The research followed the IPO framework of the study. For our input, the habitat type, which includes under the trees, bamboo, and near a water source, wherein we will need to gather the soil moisture content and then correlate it with the abundance of blueworm. The descriptive method was used in this study. The researchers sought to it that necessary permits were secured for the legal conduct of the study and that no worms were unnecessarily harmed and kept after taking the morphometrics. According to Kalu, Coralla, and Kadaka in 2015, majority of earthworms were found in top 15 centimeters of the soil. Hence, five 0.25 meters by 0.25 meters by 0.25 meter quadrats in each habitat were constructed. These are the five quadrats in the under the trees habitat, five quadrats in the bamboo habitat, and five quadrats in near a water source habitat. For the species collection, the blue worms were collected for counting within the established quadrats from each type of habitat. To prevent recounting the same sample, counted blue worms were temporarily stored in an open container and then released as soon as counting and tallying were done. For the classification of soil texture, it was classified in accordance with the soil textural classification by Ritchie and McGrath in 2015, which was adopted from S.J. Thien in 1979. It was determined by feel. For the soil moisture content analysis, 200 grams of soil were collected per quadrat from each type of habitat and then stored in plastic bags for transport. These samples were sun-dried and pulverized, and the dried samples were weighed again in order to obtain the soil moisture content, which is expressed in percentage as follows. Soil moisture is equal to the initial weight minus final weight all over the initial weight times 100. For the statistical analysis, the data were summarized into frequency tables or mean with variation expressed as standard deviation. These data went through pre-ANOVA or Levene's test, one-way ANOVA, post-hoc or ANOVA test, and the Pearson product moment correlation. All statistical analyses were computed using the Statistical Software version 7. For the vegetation cover under the tree's habitat, it was covered by different kinds of trees like dwarf and big varieties of coconuts. Tooth scrubber, balete, arrowroot, and tabiga plants were also found in the area. The bamboo habitat was composed mainly of bamboo and grass, and there were also termites inhabiting the area. For the near a water source habitat, it was not covered by any vegetation but pebbles and rocks only. For the determination of soil texture and abundance of blue worms in each quadrat, for the under the trees habitats, 18 blue worms were found with lengths ranging from 2.5 to 14 inches. For the bamboo habitat, 22 blue worms were found with 1.5 to 16 inches in length, and in near a water source habitat, there were no blue worms found. For the dominant soil texture, 100% of the quadrats includes the clay soil type. Same with the bamboo habitat, while in near a water source, 80% of the quadrats has silk and 20% is sandy. For the determination of soil moisture content, under the trees, 17.5 is the mean with a standard deviation of 5.59. The bamboo habitat has a mean of 19.5 with a standard deviation of 5.7, and the near water source habitat has a mean of 7.5 with a standard deviation of 3.06. Results of pre-ANOVA tests showed that the results are homogeneous, justifying in the use of ANOVA. For the result to be deemed as not homogeneous, the probability value should be less than 0.05. For the results of the one-way ANOVA showed that the moisture content in the three habitats significantly varied. For the results to be significantly different, the probability value should be less than 0.05. For the Tukey's on a significant difference, highlighted values are deemed to be significantly different with the probability value is less than 0.05. Based on Tukey's HSD analysis, the relationship can be summarized as under the trees, soil moisture is equal to bamboo soil moisture, which is greater than the near a water source soil moisture. Now the question here is, why is it that the soil moisture in near a water source habitat is lesser than the soil moisture in the under the trees habitat in the bamboo's habitat? This is because of their soil texture. According to Shorter in 2014, the ability for a soil to retain water is partly determined by the size of the soil particle. The smaller the soil's particle are, the greater the soil surface area is, thus retaining more water in the soil. Since clay particles are small, fine, and stick together easily, there are plenty of spaces for water, but once gaps are filled, the water cannot flow through, preventing drainage. Clay tends to hold moisture, improving water qualities of soil, but reducing drainage potential. On the other hand, sand is the largest of the different types of soil. They are rough in texture, which prevents them from sticking together to each other. Coarse sand can be also a negative factor for the inhabiting earthworm because the abrasive action of sand grains damages their skin. For the correlation between the abundance of blue worm and soil moisture content, the Pearson product moment correlation showed that the abundance of blue worm is directly correlated with the soil moisture content with a correlation coefficient of 90.9505. It can be said that as the soil moisture content increases, the abundance of blue worm tends to increase. The results of this study is also seen in the study of True in 2006, which shows that less number of earthworms take place in area where there is low moisture content. Among different soil parameters, moisture content found with organic content affected the distribution of earthworms. Hence, they prefer soils with loamy texture that don't dry out more easily. Based on the data gathered, it can be concluded that the soil moisture content under the trees and bamboo habitats is the same and is greater than the soil moisture content in the near water source habitat. It also showed that there is a correlation between the abundance of blue worms and the soil moisture content. With the effects of climate change now progressing as evidenced by the increasing temperature, soil moisture will significantly decrease, hence impacting on the density of blue worms. Blue worms are food to some birds, amphibians, and reptiles. If the blue worms' densities are low or if they have receded to lower depths, the organisms that are dependent for them in food will have less food to eat during the summer months, and so will the fertility of the soil and agriculture as well. With the decrease of natural soil enhancers, soil fertility cannot efficiently be enhanced, thus production of agricultural products during the summer months will be low. In considering the importance of blue worms in the soil ecology, it is important to consider the conservation of soil moisture in order to ensure the presence of blue worms in the soil, which could be attained through conserving trees as they are able to conserve water, especially in watershed areas. That ends my presentation. Thank you everyone for listening and to the panelists for taking the time to critique my research. Stay safe.